Hello everyone, welcome back to our channel. We are back again with a new video, Python program to convert gray to binary code. So let's start this. In the first line, this defines a function called gray to binary that takes one input parameter, that is gray str. Now in the next line, this is a docstring that explains what the function does. It's like a comment that helps us understand the function's purpose. Here, gray str a string of gray code and the return is used. The function returns the binary code corresponding to the gray code. Now in the next line, in this line, here gray str, this accesses the first bit of the input gray code, and here binary code, the first bit of the binary code is the same as the first bit of the gray code. For example, we can see that if the gray code is 1101, the first bit of the binary code is 1. Now in the next line, here, this loop goes through each remaining bit of the gray code starting from the second bit I is equals to 1 up to the last bit length gray str. Reason for starting at 1 is we have already handled the first bit in the previous step. Now in the next line, in this line, this refers to the previous binary code bit because the binary code is built step by step. Here gray str, this is the current gray code bit. Now here the binary code, the XOR operation compares the current binary bit with the current gray code. It compares the binary bit from I-1 to the current gray code bit gray str I. XOR returns 1 if the bits are different and 0 if they are at the same time. For example, if the previous binary bit is 1 and the current gray bit is 0, XOR gives 1. If the previous binary bit is 1 and the current gray bit is 0, then XOR gives 0. This converts the result of the XOR operation, which is either 1 or 0, into a string so it can be added to the binary code. Here in the next line, this appends the newly calculated binary bit to the binary code string. After processing each gray code bit, the corresponding binary bit is added to the binary code. For example, after processing the second bit, if the binary code so far is 1 and the calculated binary bit is 0, the binary code will become 10. Now in the next line, after processing all the gray code bits, the function returns the complete binary code as a string. For example, if the gray code was 1101, the binary code will be 1001 and that will be returned by the function. Now we can move in the next line in the main program. Here the program asks the user to enter the gray code. This input is stored in the variable gray input. For example, if the user enters 1101, gray input will be 1101. Now, in the next line, this line checks if all the characters in the gray input string are either 0 or 1. This ensures the input is a valid gray code. All bit in 0 1 for bit in gray input. Now this loops through every character in gray input and checks if it is either 0 or either 1. Now in the next line, this calls the function gray to binary to convert the gray code input to binary code and prints the original gray code and the corresponding binary value. Here in the next line, gray code consisting only of zeros and ones is valid. If the user enters something that is not a valid gray code like characters other than 0 or 1, The program prints a error message that the input is invalid. Please enter a valid gray code consisting only of zeros and ones. So let us check this program. I am entering a binary code. Hence, gray code is 1001 and its corresponding binary code is 1110. So thanks for watching this video.